Our next speaker is Alex Paxton, who is coming up now. She is an assistant professor in psychological sciences at the University of Connecticut. She's a former BIDS fellow and also a former postdoctoral fellow at the Institute of Cognitive and Brain Sciences at Berkeley. And she has a PhD in cognitive and information sciences from UC Merced. Now she's going to talk about an open source software community, maybe.
All right, wonderful. Hi, everyone. I am absolutely delighted to be here. Thank you to the organizers for putting this all together. It's great to be back and see all the exciting work that everybody's doing in all these different areas. So I am going to be talking about the octo-source community, which is a pun on GitHub, which has the octo cat as their logo. So what we're interested in, so this is something that I'm doing with Nell, who is a biostatistician, Stuart, who's an ethnographer, and Chris, who's a neuroscientist, and we're all bound together by our interest in understanding these communities from kind of two different perspectives. One of them is understanding open source software needs, because a lot of people are interested in, and active in that field. And some of us are also interested in just understanding community dynamics, and this, for some reason that I'll talk about today, is one exciting way that we can blend these two, hopefully to some real impact. So coming from psychology and psychological sciences, one thing that's kind of really interesting now is this idea of naturally occurring data. And these are data that are not created for any scientific purpose, but they're repurposed for that scientific purpose. And this is not going to be something new to y'all, because this is something that a lot of us all do in this kind of field, where we're finding these naturally occurring data and we're understanding human behavior or other processes as a result. So when we think about this in terms of kind of digital traces of human behavior and cognition that people are leaving as they move around their world and interact with it. These data are not kind of emerging fully formed, from the head of Zeus. This is something that people are actively working with and leaving behind their human behavior and cognition and emotion as a result. So whether that's looking, for example, at Google Trends to understand the spread of the flu, or understanding social media data to understand large-scale emotional and behavioral patterns, even looking at video game data and stock market trends, and even now health records. We have all of these different ways that we as humans leave behind these traces. We can really start to use them meaningfully if only we have the right tools. So for this project, we're specifically looking at GitHub, which, if you're not familiar with GitHub is a platform for software collaborative development, or any kind of code collaborative development. And this is really nice for a couple of reasons. First, as a collaborative platform, we can use it to look at community formation, maintenance, and health, partially because this is almost exclusively an online community. Developers can get together and work on a project without ever having set foot in the same room. And some people will be collaborators, close collaborators on these projects for years and never meet their partner. As a result, we have, this very long history of everything that they have done together, the ways that they've worked and communicated and grown and bonded together, and contributed to this community in very meaningful ways, in a way that gives us this nice microcosm. Because in psychological sciences, it can be really hard for us, for using, for example, social media data, for us to disentangle the effects of some kind of real-world offline behavior and the traces that we're seeing online. We can't really see the whole picture of that community formation and maintenance as a result. But with this, we get this very, very unique slice of being able to look at that. So that's kind of the community side of things, why we're interested in that from that perspective. But at the same time, again, there's this interest in helping the open source software community. And by this, I mean these are community maintained code and code bases. And this is super important, not just to very small niche products, but also to what we might call a walled garden. So these kind of pay for play, these kinds of communities that are maintained with paid developers, but also ones that are completely open source and completely available. You'll see a lot of different projects here that fall under this open source community that all of us use. So things like Python and database structures. Git and GitHub. Git is one of those things right there. The tools that we all use to collaborate and work. So by understanding the importance and health of this, it's really important. But we see that increasingly among open source contributors, this realization that this is a really fragile community because the majority of these are volunteer driven. That means that nobody is getting paid. They're investing their own time on their own dime to do this. And as a result, it can make it very fragile and sensitive to losses. That if you lose a couple of very key people, it can be very devastating for a community. And at the same time, kind of adding to this, we're increasingly also recognizing the harm of toxic communities, that people aren't just leaving these communities because they have lives and jobs and families, but because there are things about those communities that are actively driving them away. Kind of a case in point is this, recently, Guido van Rossum, who was the former benevolent dictator for life, BDFL, for Python, stepped down. This, he was instrumental. He created, again, took this term, benevolent dictator for life. But recently, after the most recent Python, basically large-scale release, he said this quote, "Now that this release is done, I don't ever want to have to fight so hard for a release and find that so many people despise my decisions. The toxicity of this community drove him away. He stepped down and he refused to nominate a successor. He's still involved in to some degree, but he completely took his hands off of any kind of governance. And this was a major loss to the community." So this is kind of a very flashy, high-profile loss, but we also see that just everyday contributors are also super important. So this here is a plot of what we might call a bus factor, which is this concept of how many people in your community need to get hit by a bus before you are no longer able to maintain your code. So what we see here, this is the normalized commit rate. In other words, how many contributions are people giving in your community by these different projects. And this is the proportion of how many commits, how many additions, how many contributions they're giving relative to how many contributors are doing that. So what you can see is that at about 5, the majority of these projects, 5 people are responsible for the majority of these contributions. That means if 5 people disappear from this community, there will be major problems about how do we have the institutional knowledge, how do we have just the time and effort, all of these to continue maintaining these, again, very vital resources. And so there's this understanding that we need to recruit and maintain these contributors. We can't just have them and then have them leave. We need to make sure that we foster this community. So to do this, keeping these kind of dual interests in mind, what we want to do with this project is to address psychological questions about how these communities maintain and develop and all of that. And then we also want to have these applied concerns in the open source software community so that we can use our findings to give back to this community and help make informed decisions about that. So for this project, which is still in the works, but I'd love, like my collaborators and I, some of whom are here, we'd love to hear your thoughts and feedback. But we're going to talk about two of the questions that we're answering with this today. One of them is kind of a basic question: what does the emotional tenor of these communities look like? How there's this intuition that it's really toxic and harmful. What does it actually look like? So with this one, we want to understand the patterns of language use and emotion in the online interactions that they're having. And then once we have this kind of better picture of just what's going on the ground, we then want to ask how the communication dynamics that we identify in the first question will affect newcomer retention. What makes someone get stressed out and want to leave versus someone kind of like just shoulder to the grindstone and really keep going. And so to do that, we want to model community fragility and growth by different patterns of communication that we identify from the first question. So for this, we again had the GitHub data set, and so we took 8 open source communities. This is just a representative slice of the kinds of open source projects that are happening. These are small communities, about a dozen or 2 developers, all the way up to hundreds of developers, and we chose these as being because for the first pass, these are well-established projects that are actively developing, primarily or almost exclusively on GitHub, which is what we wanted. Although this could be, and we hope to expand it to more projects as we move forward. So using the GitHub API, we were able to automatically obtain text data and other information about these projects. So the text data that we're primarily focusing on from this are issues, and issues are basically one of 2 types. One, they can suggest a fix to a problem. They can submit a pull request, is what we call that, to say, hey, I found this problem, here's how I think you should fix it. And they submit their suggestion through that. They can also flag a bug, say, hey, I tried this, it's not working, or even ask a question, how do I get this to work? How can I suggest this new function that might be helpful to the community? Things along those lines. And then in response to that, in response to these issues, users can post comments, which can kind of, any response that someone has to one of these issues in a threaded format. But basically, they're kind of two different things that people will do. They'll request additional information, hey, I can't reproduce this, how do you do this? Other, kind of clarifying information, or it got covered up, but they can express support or rejection of the ideas put forth by that original poster. So to give you an idea of what these data look like, so this is a screenshot of one of the projects in our code, or in our database data set, and this is what an issue looks like. We've got the user, we've got a date when they submitted it, we've got their, how they interact with the community, whether they're part of the community or not, and then the text of what exactly they're posting. And then after this, we've got in threaded format all of the comments that come from that issue, where again we've got the users for each of these threads, how they relate to the community, and the dates and the content. And so from this information, we can then extract from both of these two sets, the issues and the comments, we can extract a number of different metrics. And I'll be talking about 4 of them that we're looking at today. So we've got 2 measures of language use. So one of them is sentiment, so how positive or negative the content of that message was. And we used Vader sentiment, which is kind of a context-sensitive and bag-of-words approach. It's also very nice for online sources of data because it's sensitive to things like capitalization and punctuation and emoji. So if you have something written in all caps with a lot of exclamation points, it's going to be sensitive to that in a way that other kinds of bag-of-words approaches might not be. And then we also were interested in gratitude because there's, in psychology, we understand that feeling valued and feeling, gratified, like people appreciate you is really important. So we wanted to understand how people are using gratitude words. And so for this, we just did a simple word count of 11 gratitude-related unigrams, just pulled that out and looked at how that was in both of these. So then we also took some community metrics for each of these. So for each comment and issue, we were able to extract user standing. So it's whether someone was considered a member on GitHub of that organization or a non-member when they posted. So just this is again sensitive. So if someone eventually became a member, we would have that association at the time of their post, whether they were a member or non-member. And then we also have a measure of responsiveness. So with this one, we're interested in seeing how quickly the community will respond to an issue to say like, okay, we recognize this is a problem. Let's all address this together. And so this is just looking at how long it takes until an issue is closed or resolved. So with this, kind of giving you an idea of the data that we have 8 unique projects, again, just as our starting sample here. We have over 6,000 unique users, over 18,000 unique issues, and over 76,000 unique comments. So while this is just kind of a very relatively small slice of the open source community, this is we've still got a lot of power here that we're interested in looking at. So I'm going to be talking about 3 different models that we used to look at those 2 different questions. So for our first question, we wanted to look at how positive community members versus non-community members were. So when someone comes in, are they encountering friendly faces or are they encountering angry faces? So with this one, we created a linear mixed effects model where we predicted sentiment, so positive or negative, from -1 to +1, with contribution type, so it was an issue versus a comment, community membership, whether they were a member or a non-member at the time, and the interaction of those 2 variables. And what we find when we look at the message sentiment by contribution, which is comment in green, issue in orange, sentiment along the y-axis, member on the left and non-member on the right. What we find generally is that there's more negativity in issues. People are reporting issues and they're using more negative language when they do that, which kind of makes sense. People are reporting an issue which might include a lot of words like not working, other kinds of issues that might affect why people are using these negative language. But interestingly, there's also more negativity by non-members, which was not what we expected to find. We expected that members would be more negative because of this perception of toxic communities. But we don't find that. We find that non-members are generally more negative. And interestingly, in the interaction term, we find that the most positivity is evident in comments by members. So this is suggesting that when you look at issues And comments generally, there's very little difference between members and non-members, but we've got this nice little ray of positivity coming from the members when they're responding to other people's issues. It doesn't matter that we haven't looked specifically at whether or not they're responding to members or non-members' issues, but when a member posts a comment, it tends to be more positive, which was very exciting and unexpected based on what we were expecting. So our next question was looking at a gratitude, understanding how people are expressing gratitude to the other people in the community. So in this case, we predicted, again with a linear mixed effects model, expressions of gratitude with contribution type, issue or comment, community membership, whether or not they were a member or not when they posted, and the interaction of the two. And when we look at this with very similar graph, except now we're looking at gratitude along the y-axis, we see no effective contribution type, so people are not more grateful when they're posting an issue versus a comment, but we see more gratitude by non-members. So that means, what we think here is happening is that there's more appreciation and understanding for the time and effort involved by people who are not in the community for the community members who are resolving it. So they're saying, thank you so much, I'm coming to you with this problem, I really appreciate your time, things along those lines. And we see the least amount of gratitude when we look at this interaction in members' issue posts. So what we're seeing is that non-members are expressing appreciation and gratitude for people who are investing their time when they're talking to members of the community. But when members of the community are talking to each other, there's very little appreciation of that time. When members post an issue, they don't say, thanks so much, fellow community members, for investing your time and effort. It's like, this is a problem, period. Move on. So we're seeing this kind of difference in the sensitivity of language and community dynamics as a result. So those are kind of the basic questions we were interested in tackling, looking at how the community talks to itself and to non-members. So next, we wanted to apply those to look at how we can understand community membership retention. So for this, we wanted to plug in those variables that we had found before and see what makes someone stay or go. So to do this, we predicted whether or not a first-time poster would come to make a second post based on the conversation around that first post, what had happened as a result. So to do that, we predicted that in the linear mixed effects model with the information that came from the commenters. So the sentiment that the commenters used when they were replying to this issue in the comments, and their gratitude that they expressed in it as well, and then the amount of time open, so how responsive the community was to the issue that was brought to them. So when we look at this, we're going to be seeing time open in days along the y-axis, the sentiment score along the x, with a retained newcomer in blue and a lost newcomer in red. So what we find is that there's no effective gratitude. Interestingly enough, although we see a lot of gratitude that just generally happens through the community. When non-members are talking to each other, we don't see that having more gratitude expressed at your contribution. That doesn't predict whether or not you'll come back. But we do see that there's greater retention when someone is positive to you. When you, as a newcomer, show up, they might not say thank you, but if they're more positive, you'll be more likely to come back. But overwhelmingly, the most powerful effect in this is how quickly the issue was resolved. So people who are lost, we see this, this very large effect of what happens when, they come back or they don't come back. So here we're looking at the linear fits as the dark lines, and then the best quadratic fits in the lighter line behind it. So we only did the linear fit for this. We weren't interested in the kind of the higher order, but this is suggesting there's something interesting going on if we do capture that nonlinear fit, because we see that there's no difference if you look at the very, very negative comments, right? There's almost no difference between those who stay and those who go. But then as that sentiment increases and time increases, we do start to see those two groups kind of pull apart. So discussion, kind of takeaways from what we found. So when we ask our first question, what these communities look like generally, we see that, and our second question, which is about how they stay or go, we find that contrary to what we expected to find, these community members are surprisingly positive, especially as they're coming to people who are coming to them with problems, which is very encouraging. But we do see this disparity between how the gratitude is expressed for members versus non-members. So, non-members are saying, thank you so much for volunteering your time, but there's this kind of, jadedness that other people who, once they're in the community, kind of feel. When we're thinking about what makes someone stay or go, we see that positive reinforcement and quick responses to newcomers may be the best ways that we can encourage people and get them to stay invested. And so interestingly, while OSS community members, tell people that they want to feel grateful, that's not something that we see, as a powerful factor to keep someone involved. So that's kind of an interesting thing that we want to kind of think about and suss out why that exists. So future work, we want to look at what these possible drivers of the effect might be. So for example, are the people who are getting fast response times happening because they're able to identify these very solvable problems, or is there something else that's happening? And we also want to look at these individual projects and understanding how these different cultures of responsiveness, positivity, gratefulness grow. And so just kind of a final takeaway of kind of where our project is right now. We see that these kind of real world data can help us understand these kind of social and cognitive effects that we're really interested in psychology, but we're also able to then apply those to improve these complex and very high-stakes situations in very applied ways. So thank you so much. Thanks again to the organizers and to my co-authors.